Hello, good evening. I'm here to explain the final project on closest pair of points. My name is Manikantareddy. The main problem statement is to find the closest distance between the points on a two-dimensional plane. So we are having the inputs given in the question. The main objective is to explore the practical performance between two algorithms. Those are brute force algorithm and divide and conquer rules. We applied solving this problem using these two algorithms. So brute force algorithm mainly involves calculating the distance uh, between the every pair of points and selecting the minimum distance. This approach has a time complexity of big of n square. Here n is the number of points. Despite its simplicity, brute force can be impractical for larger datasets due to its quadratic time complexity. And also, from the other hand, divide and conquer algorithms. The algorithm offers a more efficient solution. It works by recursively dividing a set of points into smaller subsets, solving the problem for each subset and combining the results in the end. The key insight lies in realizing that the closest pair of points can either both lie in the left half or in both in the right half, or in each half also, each the boundary between them. This divide and conquer algorithm typically consists of three main steps: divide, conquer, and merge. First, the set of points is divided into two halves based on the x coordinates, and then algorithm is it merges the solution from two halves while also considering the pair of points whose distance crosses the boundary between the halves. So this is here is the pseudocode for divide and conquer algorithm, which is discussed, and here is the brute force pseudocode algorithm. And I have already discussed the runtime answers for brute force algorithm, that is big of n square, theta of n square, and the runtime analysis is for divide and conquer is big of n log n. And here is the code that I ran in the online compiler for both divide and conquer and brute force algorithms. And this is the code for divide and conquer algorithm, and this is the code for brute force. This is the executed output of my code. I have pasted the same code in my document here. I have run the code for 10 inputs from 10,000 to 55,000. I have given the same screenshot here, output screenshot. These are the output values I have pasted in the document. This is the table for brute force algorithm that I have constructed on n values from 10,000 to 55,000 on the theoretical values, which is n square, 10,000 into 10,000, that is 100 into 10 to the 6. The empirical root value is calculated using the from the code that I have executed and copy pasted them in the third column empirical root value, and the ratio is calculated with the empirical value divided by theoretical root value. The predicted value is the highest number of ratio calculated to the n square value. So here I have written the formulas that I have used in the table for brute force, and the same has been used for divide and conquer rule as well. But the theta value is changed here in log n. Based upon these values, I have calculated these last two column values. I have given the formulas as well according to that. And the graphs that I have calculated using this code, brute force for the n values, empirical values, and predicted values. I have given the labels and values on the x-axis and time on the y-axis. And I have given the title as brute force. The same way the output has come. Brute force with x-axis and n values, and y-axis with the time. And divide and conquer empirical root values, predicted value. In the same case, I have given the screenshot according to that. It is going straight. The predicted value is going straight, and the empirical values have few distractions on the x-axis. Empirical runtime of brute force and divide and conquer we have compared. So we are given the brute force values of empirical values of and the divide and conquer empirical values calculated accordingly. So from the graph, you can see that brute force is labeled with the blue color, is going and increasing in the parabola, and divide and conquer rule, the empirical values are going in a straight way and going in a slight increasing manner. So I want to conclude that the both algorithms efficiency comparison, while brute force and divide and conquer algorithms can find the distance between closest pair of points, later others significantly more efficient solution, especially for the larger data sets, by leveraging recursive divide and merging techniques. Advantages of a divide and conquer rule. Empirical data decisively showcases the superiority of the divide and conquer rule over the brute force methods. We have already discussed the running complexity. We know that divide and conquer rule scalability is readily apparent. We can say that it is suitable for the larger data sets when compared to brute force. Brute force algorithms runtime grows exponentially by expanding input sizes, and also the algorithm selection is experiments that underscore the critical importance of judicially selecting algorithms for problem-solving endeavors. The theoretical analysis furnishes valuable insights into anticipated efficiencies, while empirical observations validate only the performances of the algorithms. You can say that, in summary, both predictions and the findings converge to endorse the divide and conquer algorithm superior over brute force for the closest pair algorithm. The empirical validations align with theoretical expectations, affirming the divide and conquer approach's practical efficiency. Thank you.